March 1943, somewhere over occupied France. 20mm cannon shells ripped through the freezing air at 2,800 feet per second, tearing into the aluminum skin of a British Wellington bomber. The left engine exploded in a ball of orange flame. Sergeant William Crawford watched in horror as his wingman's aircraft disintegrated, pieces of metal spinning into the darkness below. 7 men, gone in 3 seconds. The German Bf-109 that killed them banked hard, its pilot already searching for his next victim. Crawford pushed his throttles forward, but his Wellington could only manage 235 miles per hour. The German fighter was doing 380. There was nowhere to run. There was nothing to do but pray. That night, 12 British bombers left England. Only 4 came home. This was not unusual. This was normal. This was 1942, and Allied bomber crews were dying at a rate that made survival statistically impossible. But across the English Channel, in a quiet factory that smelled of sawdust and wood glue, a group of furniture makers were building something that would change everything. They were building an aircraft from wood, and when German pilots first saw it, they laughed. They called it a toy. They said it would shatter like a chair thrown off a roof. They were wrong. Within 18 months, that wooden aircraft would become the deadliest thing in the European sky. It would fly faster than any German fighter. It would survive damage that would destroy metal planes. It would kill over 1,200 German aircraft and drop 26,867 tons of bombs on enemy targets. And it would do all of this without a single defensive gun. This is the story of the de Havilland Mosquito, the aircraft that broke every rule of modern warfare and won anyway. The situation in 1940 was catastrophic. Britain stood alone against Nazi Germany, and her bomber force was being systematically annihilated. The numbers were horrifying. Between September 1940 and December 1941, the Royal Air Force lost 3,147 aircraft to enemy action. That was not a typo. Over 3,000 bombers and fighters, gone. The crews inside them fared even worse. Bomber Command's loss rate meant that the average aircrew member had only a 44% chance of surviving a full tour of 30 missions. Many never made it past their 5th flight. The problem was simple physics. British bombers like the Wellington, the Sterling, and the Halifax were designed with 1930s thinking. Military doctrine said bombers needed heavy armor plating to protect the crew. They needed gun turrets with multiple gunners firing back at enemy fighters. They needed large crews to operate all these defensive systems. All of this made perfect sense on paper. In practice, it was a death sentence. Armor was heavy. Gun turrets were heavy. Crew members were heavy. All that weight meant the bombers flew slowly, typically around 250 miles per hour at best. German Bf-109 fighters could cruise at 350 miles per hour and dive at over 400. The mathematics were brutal. A German pilot could spot a bomber formation, climb to altitude, dive for extra speed, and attack from any angle he chose. The bomber gunners would fire back, but hitting a fighter moving at 400 miles per hour from a vibrating gun platform was nearly impossible. The fighter pilot had all the time in the world. He could make multiple passes, picking off bombers one by one, because they simply could not escape. RAF commanders tried everything. They flew at night to hide from fighters. They flew in tight formations, so combined gunfire could create defensive barriers. They added more armor and more guns. Nothing worked. The German fighters kept killing them. By early 1942, some bomber squadrons were losing 8% of their aircraft on every single mission. At that rate, an entire squadron would be wiped out in 12 missions. Young men who had trained for years, who had families and dreams and futures, were being fed into a meat grinder with no end in sight. The Air Ministry in London was desperate for a solution. They had tried heavier bombers, they had tried more guns, they had tried flying higher and flying lower. Everything failed. They needed something completely different. They needed someone crazy enough to ignore everything the experts believed about aerial warfare. Geoffrey de Havilland Jr. was not what you would expect from a revolutionary aircraft designer. He was quiet, methodical, and obsessed with efficiency. Born in 1910, he grew up watching his father build some of Britain's most famous aircraft. By the time he was 25, he was a test pilot and engineer, flying the same planes his father designed. But Geoffrey Jr. had his own ideas. He spent years studying birds, watching how they achieved speed and maneuverability without massive muscles or heavy bones. The answer was always the same: lightness. Nature did not build armored flying fortresses. Nature built sleek, efficient forms that could outrun predators instead of fighting them. In 1938, Geoffrey sat down with his father and proposed something that sounded insane. Build a bomber from wood. Not partially from wood, almost entirely from wood. No armor plating, no defensive guns, no gun turrets, no gunners. Just two powerful engines, a smooth wooden body, and speed. Pure, raw, terrifying speed. Make it so fast that enemy fighters simply could not catch it. The idea violated every principle of bomber design. It sounded like suicide. Military officers who heard the proposal thought de Havilland had lost his mind. One Air Ministry official reportedly said that proposing an unarmed bomber in 1939 was like proposing a knight go into battle without armor or a sword. Another called it the most ridiculous idea he had heard in 20 years of military service. The rejection was unanimous and brutal. But de Havilland refused to give up. He kept pushing, kept arguing, kept presenting data. He pointed out that the fastest aircraft in the world at that time was the de Havilland Comet Racer, a wooden aircraft that had won the England to Australia air race in 1934. Wood was not primitive. Wood was light. And light meant fast. The key was a revolutionary construction technique using Canadian birch plywood with balsa wood sandwiched between layers, all bonded with special resin from Ecuador. When these materials were combined and cured in giant ovens, they created a shell that was incredibly strong, but weighed almost nothing compared to aluminum. The structure was called a stressed skin monocoque, meaning the outer shell itself provided structural strength, eliminating the need for heavy internal frames. Finally, in late 1939, with Britain facing invasion and desperate for any advantage, the Air Ministry agreed to let de Havilland build a prototype. They gave him minimal resources and almost no official support. Most military leaders expected the project to fail. De Havilland gathered his team in a converted furniture factory in Hatfield, England. The workers were not traditional aircraft builders. They were cabinet makers, piano manufacturers, boat builders, and carpenters. Men and women who had spent their lives working with wood now turned their skills to building a weapon of war. The first prototype, designated DH-98, took shape through 1940. It was beautiful. The wooden fuselage was sanded and polished until it gleamed. The lines were sleek and flowing, with none of the angular bulkiness of traditional bombers. Two Rolls-Royce Merlin engines, the same engines that powered the legendary Spitfire, were mounted on the wings. On November 25, 1940, test pilot Geoffrey de Havilland Jr. climbed into the cockpit of his creation and took off. What happened next shocked everyone. The wooden aircraft was not just fast, it was faster than the Spitfire fighters escorting it. In level flight at high altitude, it could hit 380 miles per hour. With the throttles pushed forward in an emergency, it could exceed 400. This was faster than any German fighter could fly at those altitudes. The test pilot landed with a grin on his face and one simple message: the Germans will never catch this thing. But the Air Ministry remained skeptical. They demanded more tests. They questioned the durability of wooden construction. They worried about what would happen if enemy fire hit the wooden frame. Would it shatter into splinters? Would it burn like kindling? The doubters had reasonable concerns. Wood had not been used in combat aircraft for over a decade. Every modern air force had moved to aluminum construction. Going back to wood seemed like going back to the Stone Age. De Havilland answered the critics with more tests. The wooden prototype was subjected to brutal punishment. Engineers fired bullets and cannon shells at sample sections to see how they would react. The results were surprising. When shells hit aluminum, the metal tore and ripped, with cracks spreading outward and entire sections peeling away. But the wood behaved differently. Impacts caused local damage, with splinters and cracks around the hit point. But the damage did not spread. The plywood layers absorbed energy and contained it. Some shells punched clean through without even detonating properly, leaving neat holes but not destroying the structure. The Mosquito, as it was now called, passed every test. Production orders came in slowly at first, then faster as the need for any advantage became desperate. Furniture factories across Britain and Canada converted to aircraft production. By early 1942, Mosquitoes were rolling off production lines at a rate of 60 or more per month. The first operational squadrons formed in mid-1941. Pilots who arrived for training were skeptical until they actually flew the aircraft. Then they became believers. Squadron leader Reggie Reynolds, one of the first combat pilots, later said the Mosquito felt alive under his hands. It wanted to fly fast. It begged to go faster. In May 1942, 4 Mosquitoes attacked the German city of Cologne in broad daylight. German air defense scrambled Bf-109 fighters to intercept. The fighter pilots climbed hard, spotted the British bombers heading west, and dove to attack. They closed the distance, coming up behind the Mosquitoes, fingers on triggers, victory seconds away. Then the Mosquitoes accelerated. The wooden aircraft pulled away, engines screaming, speed increasing to 415 miles per hour. The Bf-109s topped out at 398 at that altitude. Despite perfect positioning, despite the element of surprise, the German fighters could not catch them. All 4 Mosquitoes returned to England without a scratch. German intelligence received reports of the encounter with disbelief. Wooden British bombers that outran metal fighters? Impossible. Propaganda broadcasts from Berlin mocked the plywood plane as proof that Britain was scraping the bottom of the barrel. German pilots were briefed that these wooden toys would shatter like furniture when hit. A few cannon rounds would splinter them into 1,000 pieces. But mission after mission, the Mosquitoes kept coming back. They photographed German military positions, flying over anti-aircraft guns that could not track them. They bombed precision targets like factories and railway bridges, then raced away before fighters arrived. They appeared over German cities at night, causing air raid sirens to wail and forcing thousands into shelters, then disappeared before anyone could find them. The Luftwaffe was learning a painful lesson. The aircraft they had laughed at was becoming the aircraft they feared. But in the summer of 1942, German pilots still believed one thing. If they could just get close enough to fire, if their bullets could just reach that wooden fuselage, the Mosquito would fall apart. They just needed one chance. One moment when luck ran out. What they did not know was that the mosquito had another secret. A secret that would turn the hunters into the hunted. In Part 2, we will see what happened when German pilots finally caught a mosquito and opened fire. And we will discover why the wooden aircraft did not shatter, why it did not burn, and why, by the end of 1943, Luftwaffe commanders would issue orders telling their pilots to simply let the mosquitoes go. In Part 1, we saw how Jeffrey de Havilland Jr. convinced skeptical military officials to let him build a bomber from wood. We watched furniture makers and piano builders construct an aircraft that German propaganda called a desperate joke. And we witnessed the moment when 4 mosquitoes outran Germany's best fighters over Cologne, returning home without a single scratch. The Luftwaffe was confused. British bomber crews were amazed. But the doubters in London still had one powerful argument. Nobody had actually shot at a mosquito and watched what happened. Until March 1943, when 2 German pilots finally caught one. And what happened next would force the Luftwaffe to completely rewrite everything they thought they knew about aerial combat. Flight Lieutenant James Marks had been flying mosquitoes for 6 months. He knew the aircraft's strengths and weaknesses better than anyone. The strengths were obvious: speed, agility, the ability to outrun anything with black crosses on its wings. The weakness was equally clear: no guns. If a German fighter ever got close enough to shoot, there was nothing to do except run faster. On March 15, 1943, Marks and his navigator, Sergeant Philip Hayes, were returning from a bombing run over northern France. They had dropped their payload on a railway junction, watched the explosions bloom below, and turned for home. The mission was textbook perfect. Then Hayes looked up through the canopy and saw death diving toward them. 2 Bf-109s were plunging from above, using gravity to build speed that their engines alone could never achieve. The German pilots had learned. They had studied the mosquito's performance data. They knew that in level flight they could never catch the wooden bomber. But in a dive, trading altitude for velocity, they could close the gap. Mark saw them in his mirror. His heart hammered against his ribs. The Germans were doing over 420 miles per hour. They were gaining. For the first time in months of combat, a mosquito crew faced the moment everyone feared. The moment when speed was not enough. The lead German pilot was Oberleutnant Klaus Fischer, a veteran with 11 kills. His wingman, Lieutenant Werner Hoffmann, flew 200 yards to his right. Both pilots had been briefed on the wooden British bomber. The intelligence reports were clear. The mosquito was fast, but fragile. Its wooden construction would disintegrate under cannon fire. A few well-placed 20mm shells, and the aircraft would shatter like a chair thrown from a rooftop. Fischer lined up his gun sight. The mosquito grew larger in his crosshairs. 400 yards. 350. 300. His finger tightened on the trigger. At 300 yards, he opened fire. 4 20mm cannons roared. Tracer rounds streaked through the thin air like orange fingers reaching for the wooden fuselage. Marks felt the impacts before he heard them. Thump, thump, thump. Cannon shells punching through his aircraft. The mosquito shuddered violently. Fischer watched his rounds strike home, multiple direct hits on the fuselage and left wing. He expected the wood to explode into splinters. He expected the aircraft to tumble out of control, trailing debris and flame. He expected victory. The mosquito kept flying. Fischer stared in disbelief. His shells had hit. He had seen them hit. But the wooden aircraft was still in one piece, still climbing, still accelerating. He fired again. More hits, More impacts. Still, the Mosquito flew. What Fisher did not understand was that wood behaved completely differently than metal under fire. When cannon shells hit aluminum, the metal tore and ripped. Cracks spread instantly across the surface. Entire sections peeled away like paper. The damage expanded far beyond the initial impact point. But the Mosquito's construction was revolutionary. 3 layers of material: birch plywood, balsa wood core, birch plywood, all bonded with special resin and cured under pressure. When shells hit this sandwich structure, the energy was absorbed locally. The wood splintered and cracked at the impact point, but the damage did not spread. The structural integrity remained. Some shells punched clean through without detonating, leaving neat holes but nothing more. Marks pushed both throttles to maximum power. The twin Merlin engines screamed. His airspeed indicator climbed past 410, past 415, past 420. The Germans had used their diving speed. Now, in level flight, their engines could not keep up. The gap began to open. 100 yards, 200, 300. Within 60 seconds, Fisher and Hoffman were watching the Mosquito disappear into the western sky. When Marks landed at his base in England, ground crews rushed to examine his aircraft. They found 17 cannon shell holes punched through the wooden fuselage. Machine gun bullet impacts dotted the left wing. Splinters and cracks spiderwebbed out from the damage points. But the airframe was intact. The engines ran perfectly. The flight controls worked normally. A crew chief ran his hand over one of the holes and shook his head. In a metal bomber, this damage would have torn whole sections away. The aluminum skin would have peeled back. Fuel lines would have ruptured. The aircraft would have been destroyed or uncontrollable. The Mosquito looked wounded but not broken. It could be patched and flying again within 48 hours. The report went up the chain of command. Intelligence officers analyzed the encounter. Within weeks, the information reached German commanders through spy networks and intercepted communications. The Luftwaffe was forced to issue new tactical guidelines. Pilots were told to only engage Mosquitoes if they had a significant altitude advantage and could build substantial diving speed. Even then, success was not guaranteed. If the engagement did not result in a kill within the first 30 seconds, they should break off. Do not chase. Do not waste fuel and ammunition pursuing something you cannot catch. But the Mosquito had another surprise waiting. Not all versions of the wooden aircraft flew without weapons. By mid-1943, the fighter-bomber variant designated FB Mark VI entered service. This version carried 4 Hispano 20mm cannons mounted in the nose, plus 4 Browning machine guns. Combined firepower of 8 weapons, all pointed forward, all controlled by the pilot. When German fighter pilots encountered these armed Mosquitoes expecting a defenseless target, the results were catastrophic. Wing Commander Bob Braham was among the first to fly the FB-6 in combat. On June 14, 1943, over the Dutch coast, he spotted an FW-190 diving toward what the German pilot clearly thought was a standard reconnaissance Mosquito. Braham let him come. 600 yards, 500, 400. The German pilot prepared to fire. Then Braham banked hard toward the attacker. The nose of his Mosquito swung around, and the German pilot suddenly found themselves staring at 4 cannon barrels. At 350 yards, Braham pressed the firing button. All 4 20mm cannons erupted simultaneously. 600 rounds per minute of high-explosive shells reached out like a wall of destruction. The FW-190 had no time to evade. Cannon shells ripped through its engine cowling. One exploded in the cockpit. Another tore through the wing root. The German pilot bailed out as his fighter disintegrated around him. From furniture factory joke to deadliest opponent in 3 seconds flat. German pilots began reporting a terrifying new development. The wooden British bombers were shooting back, and their firepower was devastating. 4 20mm cannons delivered more destructive force than most dedicated fighter aircraft carried. The Mosquito could play offense and defense with equal lethality. Luftwaffe morale suffered. The aircraft they had mocked as primitive was humiliating them in combat. Worse, the British were building more of them. Furniture factories in England and Canada churned out Mosquitoes at a rate of over 60 per month. Production was actually easier than building metal aircraft because wood did not require the specialized aluminum alloys that were becoming increasingly scarce. By late 1943, Mosquito squadrons were flying missions that no other aircraft could attempt. They bombed Gestapo headquarters buildings in occupied cities with precision strikes. They destroyed factories manufacturing V-weapon components. They photographed German military installations from altitudes where anti-aircraft guns could not reach them. And they attacked targets in Berlin itself, flying in broad daylight, dropping bombs, and escaping before fighters could respond. The statistics revealed the Mosquito's dominance. Traditional heavy bombers, like the Lancaster and Halifax, suffered loss rates of 5.2% per mission. For every 100 aircraft that took off, 5 never came home. The Mosquito's loss rate was 2.1%, less than half the casualties, while delivering comparable bomb tonnages per aircraft. Each Mosquito crew that survived meant experienced pilots and navigators flying again tomorrow. Each heavy bomber lost meant 10 trained men killed or captured. The cost difference was staggering. German commanders faced an impossible problem. They could not catch the Mosquitoes. They could not shoot them down reliably. They could not ignore them because the wooden bombers were striking targets with precision that heavy formations could never achieve. Adolf Hitler himself demanded solutions to what he called the Mosquito problem. These wooden aircraft were photographing secret V-weapon sites. They were bombing Berlin during his radio addresses, forcing propaganda broadcasts off the air while sirens wailed. They were proving to the German people that British aircraft could go anywhere, anytime, without being stopped. The Luftwaffe tried everything. They developed new high-altitude interceptors specifically designed to catch the Mosquito. They positioned fighters at maximum altitude to attempt diving ambushes. They deployed radar-equipped night fighters to hunt the wooden bombers in darkness. Nothing worked consistently. The Mosquito kept coming, kept photographing, kept bombing, kept escaping. But German engineers were not giving up. Somewhere in the Reich, designers were working on something new, something faster, something that would finally end the Mosquito's dominance. The jet engine. In laboratories across Germany, revolutionary aircraft were taking shape. The Messerschmitt Me-262 could fly at over 540 miles per hour, fast enough to catch any propeller aircraft ever built. The Heinkel He-162 was designed specifically as a mosquito killer, cheap enough to produce in massive numbers. German High Command believed these new jets would sweep the wooden British nuisance from the sky. By early 1944, the first jet squadrons were forming. Pilots trained on aircraft that made everything else obsolete overnight. The age of propeller combat was ending. The jet age was beginning. And the Mosquito, no matter how fast or how tough, was still powered by propellers. In Part 3, we will see what happened when German jets finally entered combat. We will witness Mosquito crews facing enemies they could not outrun for the first time. and we will discover the desperate tactics they developed to survive against technology that should have made their wooden aircraft completely obsolete. The Luftwaffe had laughed at the Mosquito. Then they had feared it. Now they believed they finally had the weapon to destroy it. They were about to learn one final lesson about underestimating British engineering. In Part 1, we watched Geoffrey de Havilland Jr. convince skeptical officials to build a bomber from wood. In Part 2, we saw German pilots open fire on a Mosquito and watch in disbelief as it simply flew away. The wooden aircraft they called a toy became the fastest, deadliest bomber in the European sky. By late 1943, Mosquitoes were striking targets across occupied Europe with impunity. German fighters could not catch them. Anti-aircraft guns could not track them. The Luftwaffe had no answer. Then, German engineers delivered something that changed everything: the jet engine. Aircraft that could fly at 540 miles per hour, fast enough to catch anything with propellers, fast enough to finally destroy the wooden wonder. And in January 1945, the first jet interceptors rose to meet the Mosquitoes. What happened next would push both sides to their absolute limits. The Messerschmitt Me-262 was unlike anything the world had ever seen. Twin jet engines mounted beneath swept wings produced thrust that propeller aircraft could not match. The 262 could climb to 30,000 feet in 7 minutes. It could cruise at 540 miles per hour and dive at over 600. For the first time since the Mosquito entered service, German pilots had a machine that was genuinely faster. Luftwaffe commanders were ecstatic. They formed specialized jet squadrons with their best pilots. Training emphasized one simple mission: find the wooden British bombers, destroy them, end the humiliation that had lasted 3 years. On January 1, 1945, Flight Lieutenant Albert Miller was returning from a reconnaissance mission over the Rhine when his navigator spotted something impossible. An aircraft was approaching from behind, closing the gap at a rate no propeller plane could achieve. Miller pushed his throttles to maximum. His Mosquito accelerated to 400 miles per hour. The pursuer kept gaining. 410. Still gaining. 420. Still gaining. Miller looked in his mirror and saw a shape he did not recognize. No propeller. 2 engine pods under the wings. The German jet opened fire at 400 yards. 30-millimeter cannon shells streaked past Miller's canopy. He threw his Mosquito into a violent turn, pulling 7 Gs, pushing the wooden airframe to its structural limits. The jet overshot, its superior speed working against it in the tight turn. Miller dove for the deck, hugging the treetops where the jet's speed became a liability. He made it home, barely. Within weeks, Mosquito losses began climbing. January 1945 saw 12 wooden bombers shot down by jets. February brought 19 more. Pilots reported terrifying encounters with aircraft they could not outrun and could barely evade. The psychological impact was severe. For 3 years, Mosquito crews had confidence that speed would protect them. Now that confidence was shattered. Some crews requested transfers to heavy bomber squadrons. Others developed what medical officers called combat fatigue. The wooden wonder was suddenly vulnerable. RAF Bomber Command faced a crisis. The Mosquito had become essential to precision bombing operations. It struck targets that heavy bomber formations could never hit accurately. It photographed German positions before major offensives. It disrupted enemy communications and transportation with surgical raids. Losing Mosquito capability meant losing strategic options that no other aircraft could provide. Air Marshal Arthur Harris demanded solutions. His staff presented grim options: They could reduce Mosquito missions to minimize losses. They could assign fighter escorts, though few fighters could keep pace with the wooden bombers. They could accept higher casualties and continue operations. Harris chose a different path. He ordered tactical changes that exploited the Mosquito's remaining advantages. Jets were fast in straight lines, but clumsy in turns. Their engines consumed fuel at tremendous rates, limiting patrol time. Their pilots were often inexperienced because Germany was running out of trained aviators. Mosquito crews learned new survival tactics. They flew at extremely low altitudes where jets could not safely operate at high speed. They used cloud cover aggressively, ducking in and out of weather that jet pilots could not navigate safely. They varied their routes unpredictably, never flying the same path twice. Most importantly, they learned to turn into attacking jets rather than running from them. The maneuver was counterintuitive and terrifying. When a jet approached from behind, instinct screamed to dive and accelerate. But Mosquito pilots discovered that a hard turn toward the attacker forced the jet to either overshoot or attempt a turning fight it could not win. The wooden aircraft's superior maneuverability became its new weapon. February 18, 1945. Operation Clarion, the largest coordinated air assault of the entire European war. Over 9,000 Allied aircraft attacked German transportation networks across the Reich. Mosquitoes played a critical role, striking precision targets that heavy bombers could not hit accurately. Squadron leader Charles Patterson led a flight of 6 Mosquitoes against a railway marshalling yard near Hanover. Intelligence reported the yard was the main supply hub for German forces facing the advancing Americans. Destroying it would cripple enemy logistics for weeks. Patterson's flight approached at 28,000 feet, cruising at 380 miles per hour. The sky was clear, visibility unlimited, perfect bombing weather. Also perfect hunting weather for jets. 20 miles from the target, Patterson's navigator called out contacts. 4 Me-262s climbing hard from an airfield to the east. The jets would intercept in approximately 3 minutes. Patterson had seconds to decide. Abort the mission and save his crews, or press the attack and risk destruction. He chose to attack. Patterson ordered his flight into a shallow dive, trading altitude for speed. The Mosquitoes accelerated past 400 miles per hour. The railway yard grew larger in their bomb sights. 2 minutes to release point. The jets were climbing faster than expected. 90 seconds. Patterson could see them now. Sleek shapes with no propellers, impossibly fast. 60 seconds. The lead jet opened fire from maximum range. Cannon shells streaked through the formation. One Mosquito took hits on the wing. It kept flying. 30 seconds. Patterson held his course. His bombardier called corrections. Left 2 degrees. Steady. Steady. Bombs away. 6 Mosquitoes released simultaneously. 36 500-pound bombs fell toward the marshalling yard. Patterson broke hard left, pulling maximum Gs. His wingmen scattered in different directions. The jets overshot the diving bombers, their speed carrying them past before they could line up killing shots. Patterson dove for the deck, leveling off at 200 feet. Trees flashed past below. A jet tried to follow, but pulled up when the pilot realized he could not maneuver safely at that altitude and speed. Behind them, the railway yard exploded. Secondary detonations ripped through ammunition trains. Fuel storage tanks erupted in fireballs visible for 30 miles. The supply hub that fed German divisions facing American forces ceased to exist in 90 seconds. All 6 Mosquitoes returned to England. The aircraft that took cannon hits was repaired in 3 days. The mission demonstrated that even facing jet interceptors, the Mosquito could still accomplish what no other aircraft could: Precision strikes on critical targets delivered at speed, with losses the enemy could not inflict consistently. The statistics from February and March 1945 revealed a surprising pattern. Despite the jet threat, Mosquito loss rates actually stabilized. New tactics worked. January's spike in casualties dropped as crews adapted. The wooden bombers kept flying, kept bombing, kept photographing, kept disrupting German operations. Meanwhile, German jet production never reached the numbers needed to dominate the sky. Allied bombing had destroyed too many factories. Fuel shortages grounded aircraft that German pilots desperately wanted to fly. Experienced aviators were dead or captured. The jets that flew were deadly, but too few and too scattered to change the war's outcome. By April 1945, Mosquitoes were flying over a collapsing Reich. They photographed concentration camps for war crimes investigators. They tracked fleeing Nazi officials. They struck the last functioning military targets. One Mosquito crew photographed Hitler's bunker in Berlin just days before his suicide. The wooden aircraft that German propaganda had mocked as primitive outlasted the thousand-year Reich by decades. The final numbers told an extraordinary story. Mosquitoes flew 39,795 operational missions during the war. They dropped 26,867 tons of bombs on enemy targets. They destroyed over 600 German aircraft in air-to-air combat. They shot down another 600 German bombers as night fighters defending Britain. Total Mosquito losses to enemy action numbered 254 aircraft, a loss rate of just 2.1% per mission. Heavy bombers suffered 5.2%. The wooden aircraft achieved the best survival rate of any bomber in the European theater, while accomplishing missions no other aircraft could attempt. Newspapers celebrated the Mosquito as the wooden wonder. Stories spread about furniture makers defeating German industrial might. The aircraft became a symbol of British ingenuity, proof that clever thinking could beat brute force. In Canada, where de Havilland Canada produced 1,134 Mosquitoes, the aircraft represented national capability on the world stage. Canadian squadrons flying Mosquitoes earned reputations as among the deadliest in the entire RAF. Air Chief Marshal Arthur Harris, the man who had initially dismissed the wooden bomber as foolish, wrote his final assessment after the war ended. He called the Mosquito the greatest multi-role combat aircraft of the entire conflict. It performed every mission asked of it, better than aircraft specifically designed for single purposes. The wooden construction that experts said would fail had actually provided advantages no metal aircraft could match. But the story of the Mosquito has one final chapter that most people never hear. A chapter about what happened to the men who created it, about the price of innovation, and about a tragedy that struck just when victory seemed complete. Jeffrey de Havilland Jr., the man who believed in wood when everyone else laughed, would not live to see his creation's full legacy. In Part 4, we will learn why, and we will discover the lessons that military designers learned from the wooden wonder, lessons that shaped aircraft construction for the next 80 years. In Part 1, a man named Jeffrey de Havilland Jr. proposed building a bomber from wood when the entire world was building aircraft from metal. Military officials called him insane. In Part 2, German pilots finally caught a Mosquito and opened fire, watching in disbelief as their cannon shells failed to destroy the wooden frame. In Part 3, we witnessed the Mosquito face its greatest challenge when German jets entered combat, and we saw how British pilots adapted to survive against technology that should have made their aircraft obsolete. The wooden wonder that German propaganda mocked as a desperate joke became the deadliest, most versatile combat aircraft of the entire war. It dropped 26,867 tons of bombs. It destroyed over 1,200 enemy aircraft. It flew 39,795 combat missions, with the lowest loss rate of any bomber in Europe. But every triumph has a cost. And the story of the Mosquito has one final chapter that most people never hear. A chapter about the man who believed in wood when nobody else did, and about the price he paid for his genius. The war ended in May 1945. Germany surrendered. The concentration camps were liberated. Soldiers came home to families who had waited years for their return. Jeffrey de Havilland Jr. should have been celebrating. His wooden aircraft had helped win the war. Military leaders who once mocked him now praised his vision. The Mosquito was being called the greatest multi-role aircraft ever built. De Havilland had proven that unconventional thinking could defeat conventional wisdom. He had earned the right to rest, to enjoy his success, to watch his creation's legacy grow. But Jeffrey de Havilland Jr. was not the kind of man who rested. Even as the war ended, he was already looking toward the future. The jet age had arrived. Propeller aircraft were becoming obsolete. The next frontier was speed, pushing aircraft faster than anyone had ever flown before. De Havilland wanted to be first. In 1946, his company developed an experimental jet aircraft called the DH-108 Swallow. It was designed to explore the mysteries of transonic flight, the dangerous speed range where aircraft approached the sound barrier. No one knew exactly what happened when an aircraft reached those speeds. Some engineers believed the sound barrier was an invisible wall that would destroy any aircraft that hit it. Others thought control surfaces would fail, sending pilots into uncontrollable spins. De Havilland intended to find out personally. On September 27, 1946, Jeffrey de Havilland Jr. climbed into the cockpit of the DH-108 for a high-speed test flight over the Thames estuary in England. He was 36 years old. He had spent his entire adult life testing aircraft, pushing them to their limits, discovering what they could do. The Swallow lifted off and climbed to altitude. De Havilland pushed the throttle forward. The jet accelerated through 500 miles per hour, then 550, then 600. He was approaching Mach 0.9, 90% of the speed of sound. Somewhere in that speed range, something went catastrophically wrong. Witnesses on the ground reported hearing a loud bang. The aircraft broke apart in midair. Pieces fell into the estuary. Jeffrey de Havilland Jr., the man who had championed the wooden Mosquito against all opposition, died instantly. His body was recovered from the wreckage days later. The creator of the wooden wonder never lived to see the full measure of his achievement. He never knew that mosquitoes would serve in air forces around the world for another 15 years. He never knew that the principles he pioneered would revolutionize aircraft construction for generations. He died pushing the boundaries of flight, just as he had lived. Wing Commander Bob Bram, the deadliest Mosquito pilot of the war, with 29 confirmed kills, survived to see peace. He had been shot down over Denmark in June 1944 and spent the final year of the war in German prison camps. After liberation, he returned to England and continued his RAF career, eventually rising to the rank of group captain. Bram wrote a memoir about his experiences and became a respected figure in aviation circles. He died in 1974, remembered as one of the greatest fighter pilots Britain ever produced. The German pilots who had chased mosquitoes across European skies had varying fates. Franz Stiegler, who encountered mosquitoes multiple times and survived with 28 victories, emigrated to Canada after the war. In a remarkable twist, he became close friends with former enemies, attending veterans' reunions where men who once tried to kill each other shared drinks and memories. Stigler admitted in interviews that German pilots had been arrogant about the wooden aircraft. Combat taught humility quickly. The British had understood something fundamental that Germany missed. But the true legacy of the Mosquito extended far beyond the men who flew and built it. The aircraft demonstrated principles that would reshape aviation for the next 80 years. The wooden construction that critics called primitive was actually the first practical application of composite materials in high-performance aircraft. The birch balsa birch sandwich that made the Mosquito so light and strong was a direct ancestor of the carbon fiber composites used in modern jets. Today, aircraft like the Boeing 787 Dreamliner and the Airbus A350 are built primarily from composite materials rather than aluminum. Their fuselages use layered construction that would be immediately recognizable to the furniture makers who built Mosquitoes in 1942. The philosophy is identical. Layers of different materials bonded together create structures that are stronger and lighter than any single material alone. Engineers call this stressed skin monocoque construction. De Havilland called it common sense. The Mosquito also proved that speed could replace armor as a defensive strategy. This principle influenced the design of aircraft for decades. The SR-71 Blackbird, the fastest aircraft ever built, carried no defensive weapons. Its protection was pure speed, exactly as de Havilland had proposed in 1938. Modern stealth aircraft follow similar logic, relying on avoiding detection rather than surviving hits. Of the 7,781 Mosquitoes built during the war, only 3 remain airworthy today. These rare survivors appear at air shows around the world, where tens of thousands gather to watch them fly and hear the distinctive sound of twin Merlin engines. The Canadian Warplane Heritage Museum maintains one of these flying Mosquitoes. When it takes to the air, veterans from both sides of the war have been known to weep. Former enemies, now old men with fading memories, stand together watching the wooden aircraft that changed their lives. The aircraft that some built and some fought against. The aircraft that killed their friends or saved their lives. Museums in England, Canada, and around the world preserve non-flying Mosquitoes as monuments to wartime innovation. The de Havilland Aircraft Museum in Hertfordshire maintains multiple examples, including components from the original prototype that first flew in November 1940. Visitors can touch the wooden skin and feel the smooth surface that German pilots saw in their gun sights. The story of the Mosquito teaches lessons that extend far beyond military history. It demonstrates that expertise can be a trap. Every military expert in 1938 knew that bombers needed armor and guns. They knew that wood was obsolete. They knew that speed alone could not protect an aircraft. They were all wrong. Their expertise blinded them to possibilities that an outsider could see clearly. De Havilland was not ignorant of conventional wisdom. He simply refused to accept that conventional wisdom was always correct. The Mosquito also shows that institutional resistance to innovation is not new. The same patterns that blocked de Havilland's wooden bomber appear throughout history and continue today. Organizations develop standard practices. Those practices become doctrine. Doctrine becomes unquestionable truth. Anyone who challenges that truth faces ridicule, rejection, and professional risk. De Havilland succeeded not because the institution eventually recognized his genius, but because desperation forced them to try something they would never have accepted in peacetime. Britain was losing the air war. Traditional bombers were being slaughtered. The wooden aircraft was a gamble born from necessity, not enlightened thinking. There is one final detail that most histories of the Mosquito overlook. In the desperate early months of the war, When de Havilland was fighting to get his wooden bomber approved, he received unexpected support from an unlikely source. Lord Beaverbrook, the newspaper baron who had been appointed Minister of Aircraft Production, saw something in the unconventional design that military traditionalists missed. Beaverbrook was not an aviation expert. He was a businessman who understood that conventional thinking produced conventional results. He pushed the Mosquito through bureaucratic obstacles that would have stopped it otherwise. Without Beaverbrook's intervention, the wooden wonder might never have been built. The aircraft that saved thousands of lives and helped win the war could have died in committee meetings, killed by experts who knew better. Sometimes the most important innovations need champions who are not experts. People who ask simple questions that specialists consider beneath consideration. People who say, "Why not?" instead of "Why?" From a furniture factory in Hatfield to the skies over Berlin. From an idea that military officials called insane to the greatest multi-role aircraft of the entire war. Geoffrey de Havilland Jr. proved that the best solutions are not always the most obvious ones. He proved that materials everyone dismissed as primitive could outperform the most advanced technology available. He proved that one person with conviction could change the course of history. The Mosquito flew 39,795 combat missions. It dropped enough bombs to fill a train stretching for miles. It photographed every secret installation in occupied Europe. It shot down over 1,200 enemy aircraft. And it did all of this while being built by cabinet makers, piano manufacturers, and woodworkers who had never touched an aircraft before. The Germans laughed when they first saw it. They stopped laughing when they could not catch it. They stopped laughing when their cannon shells failed to destroy it. They stopped laughing when the wooden aircraft they mocked started shooting back. By the end, nobody was laughing. They were just watching the wooden wonder disappear into the distance, faster than anything they could build to chase it. That is the power of thinking differently. That is the legacy of the de Havilland Mosquito. And that is why this story deserves to be remembered.